In this section, we want to talk about the graphs of polar equation. In previous section, we talked about the polar grid and the polar coordinates, and we said that any points on the polar grid has two coordinates of r and theta. And when we talk about polar equation, we also talk about the equation that the variables are r and theta, like y equal, like r equal cosine theta. That's an equation which the variables are r and theta instead of x and y. And we are going to use polar grids to graph polar equations. For example, we want to graph this equation r equal 4 sine theta, which theta is in radians, and it tells us that use multiples of pi over 6 from 0 to pi to generate coordinates of 4 points. So one of the methods to graph any equations is just plotting points, replacing some number for the independent variable and find the dependent variable, and then plot the points on the coordinate plane and graph the equation. For the polar equation, we can also do that, but when we look at this equation, we see that the equation is based on r and theta. And as we see, the r is dependent based on the theta. So theta is my independent variable. So I have to replace points for theta. And I know that the theta are angles. So I need to replace some angles for theta, find the r, and then plot the points r and theta in polar grid, and then graph the equation. Since the question says use multiples of pi over 6 from 0 to pi, so we only put those points for theta, replace those points, and then try to find r. So we need a table value for r and theta. And as you see in this table, we have all the points from 0 to pi, which are multiples of pi over 6 as well. So 0, 1 pi over 6, 1 pi over 6. Next one is 2 pi over 6, which if we simplify 2 and 6 gives us pi over 3. 3 pi over 6. If we simplify, we get pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, and the last one, which is 6 pi over 6. These are multiples of pi over 6. Multiples mean 1 pi over 6, 2 pi over 6, 3 pi over 6, all the way to 6 pi over 6, which is pi. Then we plot these points for theta. We replace the point for theta. If I replace theta by 0, I get 4 sine of 0. And I know sine of 0 is 0, and 4 times 0 is just 0. So my first point is 0 and 0. And remember, when you are showing the points on the polar coordinate, the r must come first and the theta must come after. If I replace the theta by pi over 6, I get 4 sine of pi over 6. Pi over 6 means 30 degree, and I know the sine of 30 degree is 1/2. So I get 4 times 1/2, and if we simplify 4 by 2, we get 2. So the next point, r is 2, theta is pi over 6. We replace theta by pi over 3, we get 4 sine of pi over 3, and I know sine of pi over 3 is root 3 over 2, and if I simplify, it gives me 2 root 3, but since I want to find the exact point, I change it to decimal using the calculator, and it gives me 3.5 and pi over 3. And we do this for all the points from 0 to pi. And after finding the points, we plot the points on the polar grid. So we know that in the polar grid, we have a polar axis, which is the x-axis, and we have circles with different radius, radius 1, radius 2, radius 3, radius 4, And if I want to find the point 0 and 0, which is obvious, 2 and pi over 6, so pi over 6 is this line, pi over 3, 2 pi over 3, and 5 pi over 6. So 2 and pi over 6. And the second circle, pi over 6. 3.5 and pi over 3. 1, 2, 3.5. 4 and pi over 2. So we just try to find points, and you will see that we have this table. Oops. So these are the points. 2 and pi over 6, 3.5 and pi over 3, 4 and pi over 2, 1, 2, 3, 4, yep, and 3.5 and 2 pi over 3, 2 and 5 pi over 6, and 0 and pi. And if we connect the points, you will see that we have a circle. We have a circle which the center of this circle is 0 and 2. And if we change the polar equation to the rectangular equation, as we did in previous section, we can also see that we get an equation of a circle. So this is our equation. So just as a review, to change this one, to convert this one to a rectangular form, we need r squared or r sine theta or r cosine theta. So to get that, we need to multiply the whole equation by r. So r times r is r squared, r times 4 sine is 4r sine, and we know that r squared is always x squared plus y squared, r sine theta is always y, and then if we bring everything on one side and try to make a complete square from these two, by adding 4 to the both sides, we get this equation. And this is the exact equation of a center of a circle, because we said that the equation of a circle is x squared plus y squared, which is equal to r squared. If we have numbers inside the parenthesis next to the x and y, like this, h and k are the coordinates of the center, and r is the radius. So since there is no parenthesis for x, that means x is 0, h is 0, and k is 2. So 0 and 2 is the center of the circle, and the radius is 2. So we must have a circle at point 0 and 2 with radius 2. And that's what we get on the equation in the polar coordinate as well. So what's the result? The result tells me that anytime I have an equation in this form, r equal a cosine theta and r equal a sine theta, I always have a circle. If it's a cosine, the circle is along the x-axis, as you see in this picture. And the diameter of the circle, that's exactly the a, based on the number that I have here. If number is 2, that means these whole diameter is 2. If it's 4, it's 4. But if I have a sine theta, if I have sine, the circle should be along the y-axis. Let's look at another example. We want to graph the equation of r equal to cosine theta. We know the data is in radians, and we want to use, again, multiples of pi over 6 to generate coordinates for points. Okay. So first of all, we need to find points. So we create a table, replace points for data, and find R, and then find points of R and data. Since I want multiples of pi over 6, I start with 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. I just wrote them in simplified form. Try to find R. If data is 0 and I replace data by 0, I get 2 cosine of 0, and I know cosine of 0 is 1, and 2 times 1 is 2. So my point is, remember the R must come first, and then data is 2 and 0. If I replace the data by pi over 6, I get 2 cosine of pi over 6, and I know cosine of 30 degree or pi over 6 is root 3 over 2, and simplify these two, and I will have root 3, and I know root 3, if I put it in a calculator, is 1.7. So the next point is 1.7 and pi over 6. Pi over 3, I replace it pi over 3, 2 cosine of pi over 3. Cosine of pi over 3, or 60 degree, is 1/2, and 2 times 1/2 is just 2. Sorry, which is 1, it's just 1. 2 times 1/2 is 2 over 2, which is 1. So the point is 1 and pi over 3. If I replace pi over 2, I get 2 cosine of pi over 2. Pi over 2 is 90 degree. Cosine of 90 degree is 0, and 2 times 0 is just 0. So the next point is 0 and pi over 2. 2 pi over 3. So the cosine of 2 pi over 3. So you know that 2 pi over 3 is in the second quadrant. So the cosine of 2 pi over 3, that's the same as the cosine of pi over 3, which is its reference angle, but in negative form, because the cosine in the second quadrant is negative. So I get the cosine of pi over 3 is 1/2, but the cosine of 2 pi over 3 is negative 1/2, because the second quadrant, the cosine is negative. And if I simplify, I get negative 1. So the point is negative 1 and 2 pi over 3. 5 pi over 6. The cosine of 5 pi over 6, that should be the same as the cosine of pi over 6, because pi over 6 is its reference angle. And the cosine of pi over 6 is root 3 over 2, but since it's in the second quadrant, the cosine should be negative, so the answer is negative root 3 over 2. Or you can use calculator if it's easier for you. And negative root 3 is negative 1.7. And the last point, if I replace the data by pi, the cosine of pi is negative 1. 2 times negative 1 is negative 2. Now we need a polar grid and then find the points. One, two, three, 4. I don't think we need more. Okay. So the first point is 2 and 0. The angle is 0, which means there is no angle, and the radius is 2. So let me just show the points with a different color. Next point is 1.7 and pi over 6. So let me just show the lines for the angles as well. That's pi over 6, pi over 3, pi over 2. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and 5 pi over 6. Okay, next point is 1.7 and pi over 6. So on the pi over 6 line, 1.7 is somewhere over here. 1 and pi over 3. And 0 and pi over 2. Next point is 2 pi over 3 and negative 1. So on the line of 2 pi over 3, negative 1. If it was positive 1, we had this point. But since it's negative 1, we go in the opposite direction and we find this point. 5 pi over 6, negative 1.7. Again, 1.7 in positive form is just on this side of the line. But if it's negative, we go in the opposite direction. 1.7, negative 1.7. And negative 2 on pi, which is exactly on this point. And if I connect this, so I got a circle. And I expected to get a circle because of the form of the equations. Any equations in form of a sine or a cosine is in form of a circle. But when I have a cosine, I expect that the circle is along the x-axis, which it is. And these 2 tells me that the diameter of the circle must be 2. And as you see, so this whole diameter is just from 0 to 2. If you want, you can convert this into the rectangular form and see that you get an equation of a circle as well. So let me just erase everything and show you how you can find. If you want to change it to rectangular form, remember we need to multiply both sides by r. So we get r squared, which is equal to r cosine. R squared is always equal to x squared plus y squared. R cosine is equal always x. So we need to move everything to one side, keep the x's together and y's together. I need to add something to these 2 terms and make a perfect square. And what do we add depends on the number that we have in front of the x. If we have 2, we divide 2 by 2 and it gives me 1, and then I square it, and the 1 squared is just 1. So we need to add 1 to the both sides. And then these 3 makes a perfect square, which is x minus 1 squared plus y squared, which is equal to 1. And as you see, in rectangular form, we also have an equation of a circle. So the h, or the number next to the x, is 1. K, the number with y, is 0 because there is no number. So the center is 1 and 0, and the radius, which is 1. And when we graph the equation, we also got the circle with radius 1 and the center at 1 and 0. So test for symmetry. Test for symmetry, it's very important when we are graphing a polar equation because it helps us to only graph a part of the equation, and based on the symmetry, so we reflect, reflect the other, graph the other part of the equation by just reflecting those points. So we always find the symmetry about 3 things. First, we need to see if the equation is symmetry respect to the polar axis. Polar axis is this line, or the x-axis. How do we find if it's a symmetry? respect to the x-axis by replacing data by negative data. If in the equation we replace data by negative data and the equation doesn't change and we get the same equation, that means the equation is symmetry respect to the x-axis or the polar axis. Like r equal 4 cosine data. If I replace the data by negative data, since I know the cosine is an even function and the cosine of negative data is always equal to the cosine of data, so we get the same equation, nothing changed. When I replace data by negative data and nothing changed, that means this equation is symmetry respect to the polar axis. And if I go back to the previous example, for this one, no, that's a sign, I erased that. So if you remember, when we graph this equation, we got this. We got a circle along the x-axis. And you can exactly see that the polar axis, this equation is symmetry about the polar axis. Because everything that's above the polar axis, we have exactly the same, we have the reflection under the polar axis as well. We also check if the equation is symmetry respect to the line of data equal pi over 2, which is the y-axis. So reflect about the y-axis, we can find it by replacing both r and data with negative r and negative data. This time we change both of the r and data. R should be replaced by negative r, data should be replaced by negative data, and simplify the equation. If nothing changed, we get the same equation, we can claim that the equation is symmetry respect to the y-axis. Like the first equation that we graphed, r equals 4 sine data. If I replace the r by negative r and replace the data by negative data and try to simplify this one, I see that sine is an odd function and all odd functions, the negative just go out. So instead of sine of negative data, I can say negative sine of data. And if I multiply this by 4, it gives me negative 4 sine data. On the other side, I also had negative r. Now I have a negative on both sides. I can cancel the negative by a negative, and I get r equal 4 sine data. So you see my first equation was 4 sine data, and this one also is 4 sine data. Nothing changed. That means this equation is symmetry about the y-axis. And if you remember the graph was a circle like this, which shows that the y-axis is a symmetric line for this equation. Because everything on the right side of this line is same as the left side. So one side is a reflection of the other side. And we also check if an equation is symmetry respect to the pole. Pole means the origin is this point. How do we find that? This time we only replace r by negative r. For example, I have an equation r squared, which is equal to 4 cosine 2 data. That's an equation. That's a polar equation. And if I want to check if it's symmetric with respect to the pole, I need to only replace the r by negative r. If I replace the r by negative r, since I have r squared, negative r squared means negative r times negative r, it gives me positive r squared again. So as you see, nothing changed. We get the same equation as we had. So this equation is symmetry about the origin. And if you graph the equation, you will see that whatever you have on the right side of the origin, you will have the same on the left side. That should be something like this. So Now we start checking for symmetry before graphing any equation. Because sometimes when you plot the points for graphing any polar equations, you may get only some parts of the graph, not the whole. And knowing that the graph is symmetric about respect to pole or y-axis or x-axis, it helps you to graph the rest of the equation. For example, we want to check for symmetry for this equation and then graph the equation. So for checking for symmetry, first we want to see if this equation is symmetry about the x-axis or the polar axis by replacing data by negative data. If we replace the data by negative data, since the cosine is an even function, an even function doesn't change, so it gives you the same cosine data. And as you see, nothing changed. That means the answer is yes. This equation is symmetry respect to the polar axis. Now we want to check if the equation is symmetry about the y-axis. This time we need to replace both of the r and data with negative r and negative data. If we replace r by negative r, we get negative r. But if we replace data by negative data, the cosine of negative data, that's exactly the same as the cosine data. And we get this equation. Is this the same as my first equation? No. Is there any way to cancel the negative? No, because on the other side I don't have any negative. So the answer for this one is no. This equation is not symmetric respect to the y-axis. Okay? Not symmetric. Now we want to check if it's symmetry about respect to the pole by replacing r by negative r. And if I replace r by negative r, since the right side doesn't change, but the left side, I have a negative r and I don't have any option to cancel the negative. So you see that even if you want to cancel the negative, you need to multiply everything by negative, so it changed the whole equation. So we don't get the same equation. So the answer for this one is also no. This equation or this graph is not symmetric with respect to the pole. So this equation is only symmetric about the polar axis or the x-axis. Now let's see how we can graph it. For graph this equation, we need to create a table value. Okay, replace numbers for data and find r. Okay. Again, we can replace multiples of pi over 6, 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 2 pi over 3, 5 pi over 6, and pi. And if I replace the x data by 0, I get 1 plus cosine of 0. I know the cosine of 0 is 1, and 1 plus 1 is 2. So this point is 2 and 0. If you replace pi over 6, we know that the cosine of pi over 6 is root 3 over 2. And 1 plus root 3 over 2 is just using the calculator. It gives you 1.87. So the point is 1.87 and pi over 6. If we replace the data by, we get used to x and y. So if we replace the data by pi over 3, the cosine of pi over 3 is 1/2, and 1 plus 1/2 is 3/2, which is 1.5. So the point is 1.5 and pi over 3. Here replace x by pi over 2. Cosine of pi over 2 is 1. 1 plus 1 is, the cosine of pi over 2 is 0, and 1 plus 0 is just 1. So the point is 1 and pi over 2. And the same for other numbers. So we have these points. And the coordinate and the polar grid, actually, we need to find these points. And then after finding the points and connect to each other, we get this equation. We get this graph. So 2 and 0, It's over here, sorry. Next point is 1.87 and pi over 6, 1.5 and pi over 3, 1 and pi over 2, 0.5 and 2 pi over 3, 0.13 and 5 pi over 6. It is getting close and to the 0. And the last point is 0 and pi. And you see the points are only giving you the top part of the graph. And if you find the points and connect to each other, you only get this part. But that's not the whole graph, because we know that this equation is symmetric about the polar axis or the x-axis. So that means we will have the same as the top under this line as well. So we find other points based on the symmetric property, and now we have the whole graph. That's why we always have to check for symmetric, because sometimes when we replace a lot of points, we get only parts of the graph, not the whole. And you can see that we have a heart shape. If you look at this graph, it's a kind of heart shape. So what do we resolve? Any equation in this form will be resolved in a graph, a heart-shaped graph. Why? Because they are called Limacons. Any equations in form of a plus or minus b sine or a plus or minus b cosine, a and b are numbers, are called Limacons. And based on the ratio of a over b, you can decide about the Limacon's shape. For example, if the ratio of a over b is less than 1, which means a is less than b, if a is a number less than b, you will have a Limacon with an inner loop. And you can see that here. If the ratio of a over b, means dividing a by b, is equal to 1, you will get a heart shape, like the one that we get in the last example. In this example, a is 1, that's a, and b is also 1. And the ratio of a over b is 1 over 1, which is exactly equal to 1. And if the ratio is equal to 1, I expect to get a heart shape. And since the equation is cosine, the heart must be along the x-axis. But if it was sine, I expected to get a heart along the y-axis. If the ratio of a over b is a number between 1 and 2, it's called a Limacon, dimpled Limacon. So it's not a heart shape, it's just a kind of dimple, and there is no inner loop. And if the ratio of a over b is a number greater than 2, or a is twice more than the b, we get a Limacons with no dimple and no inner loop. And you can see the picture. The heart shape are also called cardioid. If you heard these names, that means the heart-shaped Limacons. But if we have any equations in form of a sine and a cosine of n data. This time, the data is not just by itself, it's a number next to the data as well, like sine 2 data, sine 3 data, sine 4 data, cosine of 2 data, 3 data, 4 data. If we have any equation in this form, a sine and a cosine of n data, when we graph and we plot the points and we graph them, the graphs called rose curves, because we always get a graph of, including some petals. And how many petals these rose curves have, it depends on the n. If the n, or the number with data, is an even number, we get 2 times of that number petals. For example, if I have a sine of 2 data, since 2 is even, when I graph this equation, I get 4 petals, because 2 times 2 is 4. But if the equation is cosine of 3 data or sine of 3 data, since 3 is an odd number, we get exactly n petals. We get exactly 3 petals, and you can see it in this graph. Cosine of 4 data, 4 is an even number, so I expect to get 2 times of 4 petals, which is 8 petals. And you can see in the graph that we have 8 petals. Sine of 5 data, 5 is an odd number, so I expect to get only 5 petals. And that's exactly 5 petals in the graph. And the length of each petal, it depends on the number that's in front of the sine and cosine. And you can see in this one, the length of each petal is a. The length of each petal is a. Let's look at an example. We want to graph this equation, r equals 3 cosine of 2 data. So since the equation is in form of a cosine of n data, I know before graphing that it should be a rose curve. How many petals do we have in this rose curve? Since I have 2 data here and 2 is even number, I expect to have 4 petals. And the length of each petal is maximum 3. So I expect to have 4 petals for this equation. But before starting, I need to check for symmetry. So is this graph symmetry about the polar axis? If I replace the data by negative data, what happens? We have a cosine of negative data, and the cosine of negative data, that's exactly the same as the cosine of data, which means nothing changed. So we can say yes, it's symmetry about the polar axis. The equation doesn't change, so the answer is yes. For checking for symmetry for the y-axis, I need to replace both of the data on r by negative data and negative r. And since the cosine doesn't change, I still have cosine of 2 data, but the r stay negative r. That means the equation changed. So, and fails this symmetry test. So the answer is no, it's not symmetry about the y-axis. For checking the symmetry for the origin or the pole, we need to replace the r by negative r. This one stay the same. I need to fix that. But as you see, the equation changed because r still is negative, and we can't cancel that negative. So the answer for this one is also no. So this equation is only symmetry about the polar axis. When it's symmetry about the polar axis, that means everything that's above the polar axis must be reflected to get the other part of the graph under the x-axis. And for graphing the equation, I need a table value. Okay, so we replace number for data, find r. So we can replace all these numbers, and if you put more numbers, like as you see in this table, we have extra, we have some other numbers like pi over 4 and 3 pi over 4 as well. which helps us to have more accurate graph. And then after replacing this number for the data and finding the R and plot the points, we get this graph. And you can see that the graph has 4 pedals and its symmetry about the x-axis, because this part that's on top of the x-axis has the same on under the x-axis. This part has exactly the same under the x-axis, and this part that's completely above the x-axis has exactly the same part under the x-axis. But if you look at these points do not give you the whole graph. It gives you only half of the graph, because the points are only from 0 to pi. Okay, for graph for the whole circle, you need to know the symmetric, if it's symmetric about the x-axis or y-axis, and then after finding the points for half of the graph, using the symmetric property to graph the whole. Next example, we want to graph this equation, r equal 4 sine 3 theta. Again, since the equation is in form of a sine n theta, I know that's a rose curve. I should have some pedals, but since n is 3 and it's an odd number, I will have only 3 pedals when I graph it. So first I need to check for symmetry. Is it symmetry about the polar axis? If I change a theta by negative theta, does the equation change? Yes, because I will have 4 sine of negative 3 theta. Sine is an odd function, negative can be out, so we have negative 4 sine 3 theta. The equation changed, so the answer is no. It's not symmetric about the polar axis. Is it symmetry about the y-axis? Let's replace r and theta with negative r and negative theta and see what happens. So we have negative r, 4 sine of negative 3 theta. Sine is an odd function. I can move the negative out because the sine of negative 3 theta is exactly the same as the negative sine of 3 theta. Now, since I have 2 negatives out, I can cancel the negative by negative, and I will have the same equation as I had. So the answer is yes, it's symmetric about the y-axis. Okay, and for checking the symmetry about the origin, I change r to negative r, replace the negative r for r, so I get negative r, which is equal to 4 sine of 3 theta. So there is a negative here, and I have no choice of canceling this negative, so the equation changed, so the answer is no. So this equation is only symmetry about the y-axis. Now to graph the equations, I need a table value, okay, for theta and r. If I replace the theta by 0, I get 4 sine of 3 times 0, which is 0. Sine of 0 is 0, and 0 times 4 is 0. If I replace the x by pi over 6, I get 4 sine of 3 times pi over 6. So 3 pi over 6, if I simplify, it gives me pi over 2. And I know that the sine of pi over 2, or sine of 90 degrees, is 1. And 4 times 1 is just 4. If I replace the x by pi over 6, pi over 3, so 4 sine of 3 times pi over 3. The 3 cancel each other, and I will have sine of pi. Sine of pi, or sine of 180 degrees, is 0, and 0 times 4 is 0 again. If I replace the x by pi over 2, I get 4 sine of 3 pi over 2. 3 pi over 2 means 270, and the sine of 270 degree is -1, and 4 times -1 is -4. If I replace the x by 2 pi over 3, I get 4 sine of 3 times 2 pi over 3. So don't forget that we have a 3 before the data. We always have to keep that 3. These two can cancel each other. Sine of 2 pi or sine of 360 degrees is 0, and 0 times 4 is just 0. If I replace pi of 5 pi over 6, I get 4 sine of 3 5 pi over 6. I can simplify 3 by 6, and I get 5 pi over 2. 5 pi over 2, it's more than one rotation, so we get back to the, if I want to show you on the unit circle, it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So I get back to this point. And the sign at this point is just 1. 4 times 1 is just 4. And if I replace the x by pi, sine of 3 pi, which is this point, and is 0, and 0 times 4 is just 0. Now we need a coordinate, a polar coordinate. One, two, three, 4, 5, and these are, this is pi over 3, pi over 6, pi over 3, and 5 pi over 6, and okay. Now start finding the points, 0 and 0. Pi over 6 and 4. Oh, that's pi over 6, that's pi over 3, sorry. 1, 2, 3, 4. Pi over 3 and 0. Pi over 2 and negative, that's pi over 2. If it was positive 4, I had this point. But if it's negative 4, I go in the opposite direction. 1, 2, 3, 4. 2 pi over 3 and 0. 5 pi over 6 and 4. Pi and 0. Okay? And I know that this graph is symmetric about the y-axis. That means the right side of the equation of the y-axis, that should be the same as the left side. And I expect to have 3 pedals. So 1 pedal, 2 pedals, and 3 pedals. That's the graph of these equations. And you can see that everything on the right has a reflection on the left because it's symmetric about the y-axis. Now let's look at another form of equation which is called Lemniscates. And the equation of these Lemniscates are in this form: r equal a square sine, or r square is a square cosine of 2 theta. So for these equations, I always have sine of 2 theta and cosine of 2 theta. This part doesn't change. The sine of 2 theta and cosine of 2 theta. But a will be changed, and the equation is r square equal to not only r. To check for the symmetry, if the equation has a sign, it's only symmetric about the pole. But if the equation has cosine, it's symmetric about the y-axis. Why? Because, for example, in the first one, if you replace r by negative r, since we have r squared, nothing changed because we get back the same equation. So that's why we say that's symmetric about the origin. But if you change this data to negative data, you will have an extra negative on this part, and you say it's not symmetric about the x-axis. And the same for the y-axis, because for the y-axis, you also need to change data to negative data. For the second one, for the cosine, since the cosine is an even function, if you change the data to negative data, nothing changed. So that's why it's symmetric about the x-axis. Okay. If you change the r to negative r because of the s square, nothing changed, and data also, the cosine doesn't change, you can say it's symmetric about the y-axis. And if you change only r to negative r, nothing changed, so it's symmetric about the pole. So the sine is always symmetric about the pole, but the cosine is symmetric about all of them. Symmetric about the polar axis, symmetric about the y-axis, and symmetric about the origin. Let's look at an example. We want to graph r squared, which is equal to 4 cosine of 2 data. And let me show you something. The length of each pedal, it's exactly a. You have a square here. If you take the square root of that number, it gives you the length of the pedal. In this equation, when you see r squared, it reminds you the lemniscate, okay? Which means I will have 2 pedals. But these 2 pedals, since this number is 4, so a squared is 4, means a is 2. So you know that the length of the pedal should be 2. And since the equation has cosine, you know that it's symmetric about the polar axis, the y-axis, the origin, everything. So you, at the end, you should get a graph like this. And the length of the pedal is just 2. That means this point is just 2. So now that's an idea that we have before we start graphing. But now let's see how we can graph. First, we need to check for the symmetry. If we replace the data by negative data, the cosine doesn't change. So you say equation doesn't change. So the answer is yes, it's symmetric about the polar axis. If I change data to negative data and r to negative r, again, the cosine doesn't change. The cosine of negative data is the same as the cosine of data. And if you change the r to negative r, again, we get the same r squared. So the answer is yes, is symmetric about the y-axis. And if you only change r to negative r, again, the equation doesn't change because of the s squared. So the answer is yes. Now I need a table value and plotting some point. We don't need too many points in this case because we only have 2 pedals. So you can only replace some numbers like 0, pi over 6, and pi over 4. If you replace 0 for cosine of 0 is just 1, and 4 times 1 is 4. But remember that the equation is r squared. 4 equal cosine of 2 times 0. That's a 0. Cosine of 0 is 1. So you get r squared equal to 4. But you need r. So you need to take the square root from the both sides. So that's why we say r is plus and minus 2. If you replace pi over 6, 2 pi over 6. If you simplify, you get pi over 3. The cosine of pi over 3 is, the cosine of 60 degrees is 1/2. So you get 4 times 1/2, which is 2. So r squared equal to 2. Now we need to take the square root from the both sides. So the square root of 2 is 1.4. But we know that every time we take the square root from the both sides, we need a plus and minus. So the answer is plus or minus 1.4. And if you replace pi over 4, you get 4 cosine of 2 pi over 4. You can simplify, and we get pi over 2. Cosine of pi over 2 is 0, and 4 times 0 is just 0. Now we can find these points and graph the equation. So the first point is 2 and 0, and negative 2 and 0, which both of them are 2 and 0, negative 2 and 0, the first 2 points. So just write the points again. So these give me 2 points, 2, 0, and negative 2 and 0. 2, 0, and negative 2 and 0. I have 2 other points, positive 1.4 and pi over 6, negative 1.4 and pi over 6. So on the line for pi over 6, I need positive 1.4 and negative 1.4, which is this one. And the last point is 0 and pi over 4, which is this point. So if you connect the points, you will have this part. Okay, so the points only gives you this part, the red part. But you know that this equation is symmetric about the polar axis, which means everything that I have above the x-axis should have the same under the x-axis. You know that's symmetric about the y-axis and origin. And that's the equation that exactly works with all of those symmetric properties. And the last example, we want to graph this equation. R squared is equal to 9 sine 2 theta. Again, because of the R squared, I know that's the equation of the lemniscates. And since a squared is 9, means a is 3. So I know that the length of each pedal is 3. And since I have a sign here, I know that the equation must be in this form. Something like this. So first we need to check for symmetry. So if for symmetric about the polar axis, I replace theta by negative theta. So it gives me r squared, which is equal to 9 sine of negative 2 theta. Negative can be out because if it's a sine function. And r squared is equal to this one, and I can't simplify or cancel the negative, so the answer is no. It's not symmetric about the polar axis. If I replace the r by negative r and theta with negative theta, I get negative r squared, which is equal to 9 sine of negative 2 theta. Negative r squared is just r squared, but the negative for the sign can be out. Again, the equation changed, so the answer for this one is also no. To check for the symmetry for the origin or the pole, we only replace r by negative r. So we get negative r squared, which is equal to 9 sine 2 theta. And we know negative r squared, that's exactly the same as the positive r squared. So get the same equation. So the answer for this one is yes. So this equation is only symmetry about the origin. Symmetry about the origin, that means whatever you have on this part, that can be on the other side as well. But as you see, it's not symmetric about the polar axis because for everything that's above the x-axis, nothing is under the x-axis. And it's not symmetric about the y-axis because whatever I have on the right side of the y-axis doesn't have the same on the left side. Now I need to replace some point here for data. Find r. If I replace data by 0, I get r squared, which is equal to 9 sine of 2 times 0, which is 0. Sine of 0 is 0, and 0 times 9 is 0. So the answer is just 0. If I replace the r by pi over 6, I get r squared, which is equal to 9 sine of 2 pi over 6. 2 pi over 6 means pi over 3. Sine of pi over 3 or sine of 60 degree is root 3 over 2. So we have 9 root 3 over 2. But that's r squared. Okay? You need to find the r. So you need to take the square root of this. And you need to use a calculator for sure. And it gives you that the r must be equal to plus or minus 2.8. If I replace the x by, let's see, pi over 4, I get r squared, which is equal to 9 sine of 2 pi over 4. I can cancel 2 by 4 and I get pi over 2. And I know the sine of pi over 2 is just 1 and 9 times 1 is just 9. If I take the square root from the both sides, r should be equal to plus or minus 3. Now I can graph the equation. Okay, let's find the points first. First point is 0 and 0. That's a pi over 6, 9. I forgot to do pi over 6, pi over 6. This is, if you divide each quarter by 3, you have pi over 6 and pi over 3. If you want pi over 4, you need to divide the quarter by in half. So that's pi over 4. Pi over 6 and 2.8, positive 2.8 and negative 2.8. Pi over 4 and positive 3 and negative 3. So if I graph, I will have this part and this part. Okay? Since we know that's symmetric about the pole, that means everything on this side, it should have the same on the other side of the pole. And we need the whole pedals. So you can plot more points. For example, you can replace pi over 3 to see what you get. For example, if I replace pi over 3, let's see what do we get. We get r squared, which is equal to 9 sine of 2 pi over 3. And what's the sine of 2 pi over 3? That should be the same as the sine of pi over 3, which is root 3 over 2. But, yeah, that's exactly the same as root 3 over 2. So it's 9 root 3 over 2. And if I take the square root, I get the exact answer as this one. So for pi over 3, also I get plus and minus 2.8. So for pi over 3 is 2.8, negative 2.8. And you have now the other side of the pedals. And as I expected to have two pedals like that, I got the pedals as well.